Oh, g'day guys. The last type of question we're going to do in exercise 5C is looking at combining a lot of the skills that you've already learned and putting it into a graphing type question. So the first thing that we get asked to do is find the X-intercept. So if we're going to do that, let's do it. So let's get my pen up first. Right, so part A. So we've got to do that, we've got to find the X-intercept. So in other words, what we're saying is f of x equals 0. That's the case, so therefore that's equal to ln of 2x take 1 take 3. So therefore we can write that as 3 is equal to ln of 2x take 1. Now I need to solve for x, so I need to get rid of this ln somehow. The way we do that is simply making this to the power of e. Make both sides to the power of e. Now you don't really have to write what I'm doing here, but I've written it so you will know. So therefore we can say e to the 3 is equal to 2x take 1. So therefore if we rearrange that, bring the 1 across, and then divide it by 2. So x is going to be equal to e to the 3 plus 1 all over 2. Alright, so that's your X-intercept. So part B says find F0. Can F0 be found? What's the significance of this result? Now, one of the things that we need to consider when we're doing any graphing question, and I'll keep harping on it because I really want you to do this, is in fact to graph it. So if we did that, that would be ln of 0 take 1 take 3, so ln of -1. Now the first thing you could do is you could actually go to your calculator and press in ln of -1 and go enter, and basically it won't find it. The reason it won't find it is if you go to your graph and then you graph it, this is the sort of function you're getting. That's our X-intercept, and over here it's quite clearly going down over here. So what does that really mean? It means that the y-axis must be an asymptote line. Alright, so in this particular case, what would we say? No, can't find the ln of a negative number. Can't do that. So how would be a way of saying that in mathematical terms? So basically you might say I'm just waiting for my computer to load up. So you might basically look at, in terms of that, you might say ln of x doesn't exist for x less than equal to 0. Alright, less than equal to, I think ln of, you can't even find ln of 0. So less than equal to 0. Alright, so then the next part of this question obviously asks us to find the slope of the tangent at the curve when x is equal to 1. Keeping in mind, over here, we can actually find that on our calculator by simply going calc dy dx with number 6 and pressing the value of 1 in there. We can check, we know the answer is going to be 2. But we have to show it algebraically as well. So the first thing I need to do is to find the slope of the tangent, is to find the derivative, don't I? So part C, f dashed of x is going to be equal to, now that's my function ln of that over there, so that's simply going to be 2x take 1, isn't it? 2x take 1, the derivative of 3 is going to be 0, and then it's just going to be all over 2, isn't it? So, and we're looking to find this when this is actually equal to what value? When it's equal to 1. So therefore f dash of 1 is equal to 2 all over 2 times by 1, take 1. Now 2 times 1 is 2, take 1 is 1, so therefore it's going to give me a slope of 2. Now if they ask us to find the equation of the tangent, then we could easily do that. But we've only been asked to find the slope, so that's fine. For what value of x does f of x have meaning? Well, obviously it has meaning because it exists for all values when x is actually greater than 0. Right? So f of x exists when x is greater than 0. If x is equal to 0, it doesn't exist, does it? As we've basically shown you. And then basically it says find the second derivative and hence explain why f of x is concave whenever f of x has. So if we do our second derivative, alright, so let's do that. E, our f double dashed of x. Now, thinking about that, like we've got 1 over 2x, take 1, so you could write that if you wanted to. You could write this thing over here as 2x take 1 to the negative 1, isn't it? So that will give you negative 2x take 1 to the negative 2 times by 2. So that's going to give me a value of negative 4 all over 2x take 1 squared. For this value, we know that 2x take 1 squared is always going to be greater than 0. Doesn't matter what value of x is. And so therefore, negative 4 all over 2x take 1 squared is always going to be less than 0. So if I do my sign diagram for my second derivative, for all values of x, then we know that's always going to be negative. Now what we know about that is when the second derivative is negative, it means it's going to be concave. So therefore, concave for x greater than 0. Remember, x can't be less than 0, so it's going to be concave. Now if we graph that, that's the next part of the thing, is actually to graph this, and we can see it's concave for all values there. Okay, so it sort of matches what we were expecting to see on our calculator. Again, it's one of those graphy things. Whether you get asked to graph an exponential or logarithm, it doesn't really make much difference. You're doing the same sort of steps. So good luck with those questions. Make sure you catch up with me if you need some help.